Hey, what's up guys? This is Ryan Thaxton and today I'm going to be doing problem 9.1. Now, problem is an air standard Otto cycle. It has a compression ratio of 9 and a heat addition per unit mass, or QN, of 1,350. Heat addition, QN. Alright, so at the beginning of the compression, P1 equals 100 kilopascal, and T1 equals 300 Kelvin. So if you look at the tables, table A20, you'll find that PR1 equals 1.386, V1, well, we don't know V1 yet. V1 will just leave blank, and U1 equals 214.07 kilojoules per kilogram. Alright, now because of the compression ratio, we know that R equals P1 over P2. Now R is 9 in this case. So P2 equals 900 kilopascal. Right? So next we move on to the to finding PR2, and we know because of PV diagrams, PV, this is 1, 2, 4 Otto cycle, that it's isentropic. So isentropic is same entropy from 1 to 2 and 3 to 4. So for an ideal gas, there's a formula, P1 over P2 is equal to PR1 over PR2. That'd be 100, 900 equals 1.386 divided by PR2. If you do the math, PR2 equals 12.474. Awesome. So now we move on. So now we look at PR2 in the tables and try to find T2. Well, to find T2, we have to interpolate. Yay. Everyone's favorite tedious work. Alright, so T2 minus 550 equals 560 minus 550. It's pretty bad looking. 12.66 minus 11.6. If you do the math for that, T2 will equal 557.7 Kelvin. So we go down, and we know V2 is equal to V3 from the PV diagram, right? Whoops. 2, 3, V2 equals V3, and V1 equals V4. So we can find P2, V2 equals RT2, and P1, V1 equals RT1. And we find that 900 times V2 equals 8.314 times 557.7. And here we have 100 kilopascals times V1 equals 8.314. Oops, forgot the molar. Don't forget the molar mass. 20.97 times 300 Kelvin. So, do all that. We find that V2 equals 0.1778 and V1 equals 0.861 meters cubed per kilogram. So now that we have V2, we can interpolate to find, or now that we have T2, we can also interpolate to find U2. Interpolate T2, or yeah, T2. So, minus. So if you interpolate all this, six 563 minus 550, you will find that U2 is equal to 402.7 kilojoules per kilogram. Alright, and now that we have that, we can find U3. U3 is equal to Qn. Well, actually Qn is equal to U3 minus U2. So if you just add U2 over to here, you find U3. So 1,350 plus 402.7 equals 1,752.7 kilojoules per kilogram. Now we can interpolate. Now we have U3 to find reduced pressure, VR3. So if you do all that with U3 involved, you'll find that VR3 is equal to 2.445. Alright. Now to find VR4. VR4 is equal to VR3 times V4 over V3. Well, we know V4 over V3, they equal V1 and V2. Alright, so that equals 2.445 times 0.861 divided by 0.1778. That equals 11.84. So now you can interpolate. Now that you have VR4, you can interpolate with VR4 to find U4. And if you do all that, same stuff, go to table A20. It's about 20. You'll find that U4 is equal to 986.75. Right? So go down. Now that we have all the U4s, work net equals U3 minus U2 minus U4 minus U1, because it's a closed volume. Right? Q minus W equals delta U. So now we do 1752.7 minus 986.75 minus 402.7 minus 214.07, and the work net equals 577.32 kilojoules per kilogram. Great, now that we have that, we can find the thermal efficiency. So work net over Qn, oh that's easy, we already got Qn, equals 577.32 divided by 1,350, and that equals 42.76%. And now we can go and find the mean effective pressure, MEP, which equals the work net over V1 minus V2. We can find that 577.32 kilojoules per kilogram divided by specific volume V1, which is 0.861 minus 0.1778 meters cubed per kilogram. Cancel out the kilograms. And your mean effective pressure equals 845 kilopascal. That is your mean effective pressure. Great, so now we have all our values, and I will be doing 10.2 next.